Good morning, children. We proceed on to exercise 10.2.
Differentiation techniques. Let us recall the formula where constant becomes 0 as we differentiate. E power x, the derivative e power x. Suppose I have e power ax. We call this as chain rule. The rule says, first we shall differentiate e power. E power x becomes e power x. So e power ax becomes e power ax. Once I completed e power, hide it. What remains? Ax. That ax I differentiate, that becomes a. Suppose sin x is there. The derivative I call cos x. Suppose sin 2x is there. The derivative cos 2x. I finished sin. Hide it. 2x becomes 2. Similarly, log x becomes 1 by x. Log x plus 2 becomes 1 by x plus 2. Suppose I have log 3x plus 2. As I differentiate, first I do logarithm. Log 3x plus 2 is 1 by 3x plus 2. Hide logarithm. 3x plus 2 will become 3. 3x becomes 3, 2 becomes 0. And these type of problems come under chain rule. 1 or 2 of this pattern we use in exercise 10.2 itself. Question number 13. Y is equal to tan theta into sin theta plus cos theta. As we recall the formula list, it is in product rule. We differentiate y with respect to x. Keep the first term. Differentiate the second term. Plus keep the second term. Differentiate the first term. As we write the answer, we simply write dy by dx. This doesn't mean division. It is only a notation for differential coefficient. Keep tan theta as it is. Sin derivative cos theta. Cos theta derivative minus sin theta. Plus sin theta plus cos theta into tan theta, the derivative secant square theta. Write tan theta as sin theta by cos theta into cos theta minus sin theta plus sin theta plus cos theta into secant square theta is 1 by cos square theta. As we multiply, dy by dx is sin theta into cos theta by cos theta, first term, then second term, minus sin theta into sin theta by cos theta, plus sin theta into 1 by cos square, sin theta by cos square theta, cos theta into 1 by cos square theta. As we cancel, sin theta alone remains in the first term, minus sin into sin is sin square theta by cos theta. Here let us split the terms. Sin theta by cos theta into 1 by cos theta plus cos and square cancels, 1 by cos theta. As we simplify, it is sin theta minus. Combine these two terms. By cos theta, which is common. The numerator 1 minus sin square. As I combine these two terms, this is plus and this is minus. The denominator cos theta is the LCM. Numerator 1 minus sin square theta. Plus sin by cos, I can write tan theta. 1 by cos, I can write secant theta. So my answer is sin theta plus 1 minus sin square is cos square theta by cos theta plus tan theta into secant theta. Cancelling one cos and square, we are just left with dy by dx is sin theta plus cos theta plus tan theta into secant theta, and that is the final answer. Question number 14. Y equals cosecant x into cot x. As we differentiate y with respect to x, y becomes dy dx. There are two terms in product. Keep the first term, differentiate the second term, plus keep the second term, differentiate the first term. As we simplify and write, dy by dx is cosecant x into cot x, the derivative, minus cosecant square x, plus cot x into cosecant x, the derivative, minus cosecant x into cot x. As we multiply and simplify, it is dy by dx is minus cosecant into cosecant square, cosecant cube x, plus into minus minus cosecant x into cot is cot square x. Using the trigonometrical ratios, minus cosecant is 1 by sine, cosecant cube is 1 by sine cube x, minus cosecant x 1 by sine x, cot square x is cos by sine, so cos square x by sine square x. As we take LCM, it is sine cube into sine cube. Sine x into sine square, again sine cube. So sine cube is common. Take minus sine out. We are left with 1 plus cos square x, and that is the answer for dy dx. Question number 15. X into sin x into cos x. As I differentiate y with respect to x, there are three terms in product. Y becomes dy dx. RHS, there are three terms. Keep the three terms 3 times. You remember to write. We always keep 2 terms and differentiate 1 term. So first time differentiate the first term, second time differentiate the second term, third time differentiate the third term. See whether you follow. There are 3 terms. Each time I will keep 2 terms as it is and differentiate 1 term. So keep second and third, differentiate first. Keep first and third, differentiate second. Keep first and second, differentiate third. As I simplify and write, it is dy by dx. X becomes 1 sin x cos x plus x into cos x as it is. Sin x derivative is cos x plus x sin x as it is. Cos x derivative is minus sin x. As we simplify and write, dy by dx is sin x cos x plus, in these 2 terms, x is common. If I take it out, cos into cos, cos square x, minus symbol, sin into sin, sin square x. As we recall the trigonometry formula, cos square minus sin square x is nothing but cos 2x. As we recall the trigonometry formula, cos 2 alpha is cos square alpha minus sin square alpha. So cos square x minus sin square x is cos 2x, and that is the answer. Question number 16. Y equals e power minus x log x. As we differentiate y with respect to x, y becomes dy dx. There are two terms in product. Keep the first term, differentiate the second term. Plus, keep the second term, differentiate the first term. dy dx equals e power minus x into log x, the derivative 1 by x, plus log x into e power minus x becomes e power minus x. Because there is minus sign, put it here. This we call chain rule. E power minus x I write as it is. Hide e. Minus x becomes minus 1. In both the terms, e power minus x is common. So we are left with 1 by x minus log x, and that is the answer. Question number 17. Y equals x square plus 5 log 1 plus x e power minus 3x. There are three terms in product. As I differentiate y with respect to x, let us remember RHS. There are three terms. Write 3 times. First time we put derivative of first term. Then we put derivative of second term, and then we put derivative of third term. Since there are 3 terms in product, all the time keep 2 terms in product and differentiate the third term. So first time I keep second and third, differentiate first. Second time I keep first and third, differentiate second. Third time I keep first and second, differentiate the third term. So dy dx equals x square. When I differentiate, it is 2x. 5 is a constant, that becomes 0. Write the remaining 2 as it is. Plus x square plus 5 into log 1 plus x. Log will become 1 by 1 plus x. Log becomes 1 by 1 plus x. Hide logarithm. 1 constant will become 0. X will become 1. So we need not write it. Write the third term as it is. Plus first term as it is. Second term as it is. Differentiate the third term. E power will become e power. Minus 3x will become minus 3. This is chain rule. E power becomes as it is. Whatever is in the power, differentiate. So minus 3x becomes minus 3. In all the terms, e power minus 3x is common. We'll keep it out. We get 2x log 1 plus x. Plus x square plus 5 by 1 plus x. Plus into minus minus, there is a number 3, and we are left with x square plus 5 into log of 1 plus x, and that is the answer for dy dx. Question number 19. Y is equal to log x base 10. We have the formula log x derivative as 1 by x. This log x should have the base e. But in this problem, there is some other base. In the formula, we have the base to be e. If any other base is coming, let us remember change of base rule in logarithm. A base b in logarithm can be written as a base e, e base b. I am introducing e as an intermediate. So applying that here, y equals log x base 10 is there. But I want log x base e. So introduce base e and then you write e base 10. So the given question 10 has come here, we have introduced e. The next step, I can write differentiate y with respect to x. As we differentiate y with respect to x, y becomes dy dx. RHS, this is a constant. Keep it as it is because it will be treated as the coefficient now. So log E base 10 comes as it is. Log X base E. As I differentiate, my answer is 1 by X, and that is the answer. Question number 20. Draw the function f dash of x. If f of x equals 2x square minus 5x plus 3. To find f dash of x, we have to differentiate. 2 as it is, x square becomes 2x minus 5 as it is, x becomes 1. 3 constant will become 0. As I simplify, 2 into 2x is 4x minus 5. Now we need to draw the graph of f dash of x. So to draw f dash of x, the answer is 4x minus 5. Let us put some x values and find what is f dash of x. If I put x 0, I will get 4 into 0 minus 5. So what is my answer? It is 0 minus 5. I get minus 5. If I put 1, 4 into 1 minus 5. 4 minus 5 minus 1. If I put 2, 4 into 2 minus 5. 8 minus 5, 3. If I put minus 2 or I put minus 1, 4 into minus 1 minus 5. Minus 4 minus 5, that is minus 9. As we plot the points, it is 0 minus 5. 1 minus 1, 1 minus 1. 2, 3, 2, 3. Minus 1 minus 9, minus 1 minus 9. So we shall join these points to make the graph. As we have joined it using the scale, let us write down this. This represents a graph f dash of x,
which is a straight line.